Hello everyone, welcome to this session. Today we are going to talk about vectors. First, in terms of linear algebra, what does vectors mean? And then in terms, give you some examples where uh, a special version of vectors is used in machine learning and artificial intelligence. First, let's make the fundamentals clear. What do you mean by vectors? So vectors are fundamental objects in maths and physics. It has a special features, which means that it has both quantity and direction. Okay, so a vector has both a quantity and a direction. They are used in different fields of physics, engineering, computer science, and more. The arrow points in the direction of the vector. Okay. The length of the arrow, like from here to here, represents the magnitude. Okay, so which means the quantity or the magnitude, because vector has two things, quantity and direction. So the magnitude is nothing but the quantity, and this is the direction. Okay, and this is called as the head. Okay, because the vector is moving in this particular direction. Some characteristics or features of a vector, like one we said, it has magnitude or quantity, which is also known as the size or the length of a vector. Direction, okay, direction, the orientation of vector in space, like which direction it is going, up, down, slant, left, right, which direction it is going. The direction of the vector is from its tail to head. Okay, so for example, a force of 10 newtons to the right is different from a force of 10 newtons to the left. So it's either going this, is different from coming back here. Vectors are usually visualized with arrows, and they are different from scalars, where the quantities that have only magnitude. Okay, so it's not like temperature or mass. Okay, temperature or mass has only quantity, no direction. But velocity, okay, velocity has what do you call it? It has a speed, right? So it has a direction. You're going in some particular direction. You can have different operations on vectors, which we will see right now, which is addition, subtraction, okay, and the specific rules about it. Now, two vectors, they are the same if they have the same magnitude and same direction. So see here, okay, so this means that if we take a vector and translate it to a different position without rotating it, then we obtain another vector, which is the same vector that we had in the beginning. So let's say you're just taking this arrow and moving it here, but you don't change the direction. The direction remains the same. Okay, so which means this tip is not pointing to in any other direction. It's the same direction. Okay, so just you're putting it up here and just parallelly moving in here. Okay, so neither the direction changed nor the magnitude changed, just the location in space that changed. So two examples of vectors are like force and velocity. Both force and velocity are in a particular direction, right? The magnitude of the vector would indicate the strength of the force, or the speed associated with the velocity. So see here, the blue arrow represents vector A. The two defining properties of a vector, magnitude and direction, are illustrated by the red bar. So this is the magnitude and this is the direction. So if you see, this is parallel, magnitude is this. So which means from here to here, this tip is equal to from here to here. So which means the magnitude distance from here to here is 3.61, and this is its direction. See the green arrow, this one has only one length, okay, but it is the direction of the vector. There is one exception, which is the zero vector. which does not have any magnitude, and neither does it have any direction. Okay, so now having known what are the fundamentals, what is a vector actually, let's see the different operations that we can do. We can do addition, subtraction, and multiplication by a scalar. Okay, now addition on vectors. Now, so given two vectors A and B, this, if we want to add A plus B, okay, by translating the vector B, so how we do it? We do vector B and point it to the tip of A, okay? Until, see, we translate the B until it points to the tip of A, and then, so wherever the B is bent, this is A plus B, okay? So this becomes A plus B. But this is just visualizing, okay? Now here, subtraction, okay? So now before we define subtraction, see, subtraction is what? Adding the negative of it or inverse of it, right? So see, we define minus A, which is opposite of A. So it's like B minus A is equal to B plus minus A. Okay. So see here, this A plus X is equal to B, right? It is just like we do it in the scalars, right? B plus minus A is equal to B minus A. Okay. Multiplication of a vector. Now, given a vector A and a number lambda and a scalar number, real number lambda, this sign is called as the lambda. We can form the vector lambda A as follows. If lambda is positive, then lambda A is the vector whose direction is the same as of A and whose length is lambda times the length of A. Okay. Otherwise, if lambda is negative, it is going in the opposite direction. Now, scalar multiplications have these satisfies the following rules, like how we do regular multiplication rules, like distributive law, S times A plus B is equal to S times A plus S times B. Writing it the other way around, 1A is equal to A, minus 1 times A is equal to minus A, 0 times A is equal to 0. Same properties that applies to our regular algebraic equations. Same applies to vectors too. We did talk about zero vector, okay, with the, what do you call it? It's an exception to the regular vector, okay? You have zero length, okay, and with no length, the vector is not pointing to any direction, which means it has also an undefined direction. It doesn't point to any direction. Okay, now we come to the interesting part. Now that we have some fundamentals about vectors, like what are vectors, some operations that can be done on vectors, now we come to an interesting kind of vector, which is an eigenvector. Okay. Now, in the previous slide, you saw that this vector, the direction could be changed. See here, when you did B minus A, see the direction of A changed. And see here, this was pointing this way. Now it's pointing this way. The direction has changed, right, of A or the sum. Now, eigenvectors are special because even if you apply any linear transformation, the direction of the vector does not change. See, there are three vectors. These are the two red and this is the yellow one. You apply some transformation, which means you do some multiplication or something like that. And in spite of that, see, the direction did not change. The magnitude changed of the red ones, but for the yellow one, the direction changed. So the yellow is not an eigenvector, but this both red, see, this is also still going up, same direction. This is still pointing horizontal, okay, going in this direction. The magnitudes have changed. Maybe you multiplied it with something, okay? So this red is an eigenvector, which means if you apply any linear transformation to it, its magnitude will change, but its direction does not change. So the yellow is not an eigenvector because the angle was this, but now it's become slightly towards the down. See, this is the angle right now. Okay. Now, eigenvectors have a lot of usage in computer science, especially in machine learning algorithms. Like it's used in dimension reduction, it's used in special clustering. It is also used in natural language processing, NLP. The ChatGPT and Gemini, they are all based off of it. Now, dimension reduction in the sense you reduce the number of directions or dimensions that is given to a model. Special clustering, it's like when you do classification, you're doing clustering. Okay, so spectral clustering, it uses eigenvectors to group the data points. Okay, which means data points to which if you apply the linear transformation, its direction won't change. Okay, so this is all about eigenvectors that we did. um, Again, just a brief recap. Vectors are what do you call, mathematical concept, something like velocity, which has both magnitude and direction. Different operations that can be done on vectors: addition, subtraction, multiplication. We also talked about zero vector, which does not have any magnitude nor direction. We talked about eigenvectors. Eigenvectors are vectors which, when you apply the linear transformation, does not change its direction. Its eigenvectors are so important because they are used in different fields of computer science, especially in machine learning. All right, that was all about it. We're going to come up with some new concepts in the next video. Thank you all and keep learning.